Okay, hello everyone. Welcome to this Royal Aeronautical Society lunchtime webinar, a beginner's guide to sustainable aviation fuel as part of the Society's Sustainability Week. I'm Poppy Howe. I'm a doctoral researcher at Loughborough University, researching sustainable aviation fuel combustion. I'm going to be your host for today's session. Just a couple of housekeeping announcements before we delve into Dan's presentation. So the event is being recorded today, and those of you who are registered will receive the link after the webinar. I believe the recording is also due to go up on the Society's YouTube channel as well after the event. We're going to have plenty of time at the end of the session for questions, so please do pop any questions you've got into the chat, either during Dan's presentation or obviously during the Q&A itself at the end. And we're going to aim to promptly finish at about 12:45. So without further ado then, I'd like to introduce Daniel Bloch. Daniel plays a leading role in driving synergetic relationships among LanzaJet's key commercial and non-commercial partners. With a holistic value chain approach, much of his time is dedicated to identifying stakeholder-specific value propositions for SAF as to deliver the most meaningful, productive and customised engagements. Passionate about the circular economy, nature-based solutions and the delivery of a just energy transition, he also spends his time researching and identifying new potential ecosystems for the SAF industry to grow and intersect with. From there, his goal is for LanzaJet to be seen as a best-in-class partner and an organisation recognised not just for its operational excellence, but for the way it prioritises innovation, education and empathy. So Dan, thank you very much for joining us. Over to you.
Thank you very much, Poppy, for the kind introduction, and hi everyone. It's a pleasure to be with you today. And yeah, over the next sort of 20 to 25 minutes, I'll be taking you through an introductory guide to sustainable aviation fuel, hopefully break down some misconceptions and really drive home some of the fundamental concepts to best understand what we talk about when it comes to sustainable aviation fuel. From there, look forward to answering your questions at the end of the session, and we'll hopefully all go away having learned something and yeah, enjoyed the session. So without further ado, just let me share my slides. Just give me a moment. Okay, let's jump into it. So why SAF? That's really the important starting point. We need to contextualize this topic before we jump in and understand what we're dealing with. So back in 2021, the airline industry voluntarily came out collectively through IATA, or the International Air Transport Association, and determined that the airlines needed to achieve net zero by 2050. So this was, again, the airline industry proactively coming out and identifying that this was an existential need for the sector. And that's really because it understood itself as hard to abate. It understood that perhaps in that current context, they were representative of about 2% of the world's global carbon emissions, but there was a real risk as a hard to abate sector with very few options to reduce that footprint, that they had to really come out quite energetically on the front foot and identify this as a collective priority, because the risk of not doing so would mean that its 2% might extrapolate out to 10, 15% by 2050, at which point it becomes really quite a target for government restrictions and regulation, which is clearly not something that we want to see the sector. We want to see it grow, but we need to see it grow sustainably. So within that, a plan was established. You can see on the right-hand side of the screen, reference to basically the four main levers within the industry's net zero emission roadmap. And so at the top of the list, you've got sustainable aviation fuels, as well as a suite of other measures like the adoption of new aircraft technology and fleet renewal, like your 737 MAXs or your A350s, more efficient air operations and ground infrastructure, as well as the potential role of other technologies like zero emission fuels such as hydrogen and electric aircraft. But in terms of the big picture, what you're seeing here is essentially those levers mapped out into 2050. This is another IATA graph, and you can see the role there that SAF is going to play. There's a number of different roadmaps, but all of them come to the conclusion that SAF is really going to be between about 50 to 70% of the carbon abatement strategy for the airline industry. So it really underpins the centrality of this role. It is not the silver bullet, pardon me, There's clearly a role for all of these other mechanisms, but the heavy lifting is ultimately going to be coming from changing the fuel source. And of course, that makes sense, right? At the end of the day, this is an airline business. They're going to be combusting a lot of fuel. And so that is directly targeting the source. So let's talk about SAF. What is this thing that we talk about? I like to describe it in almost like a basic formula. The first function of that formula is clearly it needs to be an operationally approved fuel. So it has to be able to deliver the energy density and performance of a traditional Jet A1 such that it is fully compatible with existing aircraft technology, existing refueling infrastructure at airports, so as to have the least impact operationally, at least disruption to ongoing airline industry activities. Now, this is really what makes it quite magic, is it is a drop-in fuel. But it goes further than that as well. It also clearly, and I shouldn't be saying anything too drastic here, produced in a certifiably sustainable manner. And that equation comes to a sustainable aviation fuel in its most simplistic manner. We're going to go into what we mean by this certifiably sustainable manner throughout the course of this conversation today. But with that in mind, let's break it down. So the point around SAF is it's going to be produced from an above ground source of carbon. So I want to make this as sort of as translatable as possible. So under current sort of fuel refining operations, what you're finding is fossil fuels are derived from underground sources of carbon, which are extracted and obviously damaging the ecosystem in the process. You're unlocking long-term underground carbon stocks, and that releases into the atmosphere. And then you're combusting the fuel out of the engine. So it's a double whammy in terms of the carbon emissions that a fossil fuel is going to produce. SAF doesn't do that. We are rather sourcing elements of carbon that exist above the ground and leaving alone those that exist below the ground. Now, these can be biogenic in nature, so things that we're used to seeing around us in the form of various sources of waste and byproducts, which is generally in a physical state, or you could even have non-biogenic inputs. And this is more your gaseous feedstocks. We're going to explore that a little bit more as well. But essentially, that's where you hear the term power to liquids. We're taking essentially direct air captured carbon in a gaseous state, or from, for example, an industrial plant, which is emitting carbon out of a factory, for example. So this is our feedstock. But again, this feedstock needs to be sourced and grown or collected sustainably. It's not good enough for it to just be, for example, a non-fossil based fuel. In other words, you don't want to be deforesting large areas of land in order to grow an energy crop. You don't want to be compromising food chains for human consumption. There are a suite of different measures that we can ensure, though, that this process of growing or collecting such feedstocks is sustainable. Go into that a little bit more as well in the further of this course. The point to be made, though, is SAF as a concept relative to jet fuel saves carbon emissions across the fuel's life cycle. In other words, in the entire end-to-end process of how the fuel is made. And it can generally reduce carbon emissions by about 70 to 80%. That being said, there's obviously lower ends of that spectrum and even much higher, such that you can have negative carbon values for a SAF if it's produced and delivered, especially sustainably. So if you're to visualize this, this is the life cycle here. And as I like to say, the first step of the collection or aggregation of the feedstock that exists above the ground rather than below is really where the magic happens. Thereafter, it's a very similar process to traditional refining. You convert that feedstock and you're basically building up the carbon chains that exist from whatever material you might be using. You convert that into a SAF. You then have to ship it or transport it out to the point in which it's then fueled and delivered into the wing at the airport. And that's really the point, is that first step is where you are taking something out of the ecosystem or growing something that is ultimately going to have a positive impact on society and the environment. And that process is where you're going to derive a negative carbon value. Each of the further steps have obviously carbon related activities to them, be the distribution, the processing at a plant, or the fuel combustion. But the point to be made is the equation of one versus then steps 2, 3, and 4 married up with one another comes to some sort of net effect. And ultimately, what it means is you capture a closed loop circle in the carbon cycle. That is the point around SAF. So it is not a true zero fuel. this is true. This is not a true zero emission fuel, unlike what you might see with electric or hydrogen aircraft. However, it closes the loop. The point to be made is it's a circular economy activity in motion. We are taking things that already exist from existing industries and activities that we as humans are producing. And as a consequence, we protect the underground carbon stocks and we source those that have little value to society above the ground that we can repurpose into aviation fuel. And the closed loop and the circle goes on and on. In its most basic form, there are currently 3 pathways that the industry leverages to create sustainable aviation fuel. The first, going from the left of screen, is the most common because it's most similar to that of what we find with fossil oil refining. But rather than using a fossil oil source, we use a bio oil source. So we can think of some examples like used cooking oil, industrial greases, discarded animal fats not for human consumption. These all contain lipids and oils, which are treated through a process called HEFA, or hydrotreating. The point to be made is there's a lot of existing infrastructure that are fossil oil in nature that only need slight conversions in order to be able to treat such bio oils. This is our first starting point. From there, the next couple start utilizing different kinds of feedstock. There's a route called alcohol to jet, which uses ethanol as its intermediary, as you can see in the middle. And the reason for that name is really, it's quite similar to actually producing an ethanol. You ferment the sugar, an alcohol, I should say. You ferment the sugar, and that turns that into an ethanol. And then the non-consumed element of the ethanol is able to be converted into a fully compatible alcohol to jet sustainable aviation fuel. Finally, there's also a gasification pathway, and it's through a long-standing technology called Fischer-Tropsch. It's actually, interestingly, a technology that's existed for nearly a century. But what we're able to do now is take either solid waste material, so think of like a woody biomass or even like a plastic waste that you might find in an urban landfill, and you're able to do a basic gasification step to turn that into a synthetic gas. That synthetic gas is then put through a Fischer-Tropsch reactor to also create a fully compatible sustainable aviation fuel. However, as the name suggests, you could equally take a feedstock that's already in a gaseous state. And that helps us then take carbon from the atmosphere or at the source of a factory, emitting sort of carbon into the atmosphere itself. And that already in a syngas state can be put through a Fischer-Tropsch reactor directly. This is an oversimplification, but what it should already demonstrate is the breadth of the different types of feedstocks we can leverage in order to produce our SAF. So with that point around feedstock, we sort of understand now what we're dealing with. It's an above ground carbon source, which requires a relevant production pathway that it's tied with to enable the production of renewable fuels, such as SAF. These are also clearly the key determining factors in the integrity of a SAF's sustainability claims and calculations. It's what I was saying at the beginning, where we need to ensure that the way that these feedstocks are assessed, aggregated, or produced in order to really demonstrate that it's not just delivering a carbon saving, but it's not having impacts on the ecosystem or the population or public health and the surrounds. The other point to be made is commercially, these are really significant because they represent well over half of a SAF producer's operational expenditure. And so clearly we want to find feedstocks that are abundant in terms of their scalability and available en masse with equally low value to society. That's the real sweet spot. We're trying to find things that just don't serve us as people and a collective community with much value. So let's go through some more examples quite explicitly. The first one I've already referenced. So the traditional fats, oils, and greases like used cooking oil, tallow, industrial greases. This is a good first step. However, sort of intuitively, you might imagine there's just a threshold to how much of these waste fats, oils, and greases really exist in the world. There's only so much McDonald's that we can consume as a human collective. So the point to be made there is you do have a waste that now is becoming finite in supply. And so we're going to reach a natural threshold or plateau to how much can be possibly aggregated and put towards renewable fuels year on year. So out to 2050, this particular pathway might get us to about 5 to 10% of our industry needs. So what else comes with this whole SAF feedstock conversation? For one, you're looking at agricultural wastes and byproducts. So again, these are all activities that are already taking place. This is kind of the point I want to stress here in this section around feedstocks. We are ideally looking for things that are going to be sort of produced and discarded, whether we are making SAF or not. As I was saying, the real sweet spot for feedstock is where we are not serving society with this particular source or input. So be it through farming, be it through crop production, be it through food production, whatever it might be, the wastes and discards from agriculture represent a really strong option for sustainable aviation fuel production. Similarly, the forestry waste and residue source point becomes a really interesting option. To stress again, this is not an activity of cutting down trees for the sake of producing a sustainable aviation fuel. Rather, what you're looking for is there is an existing forestry and wood-based industry to produce furniture or materials. And there are wastes and offcuts that are just simply not utilized at the end of that process. This is another ideal example of a waste-based feedstock that is really leverageable for the sector. Similarly, urban landfill, municipal solid waste. These are equally very interesting feedstocks. And now you can already start entertaining, and this picture is a really nice example of that, in terms of not only is this massively abundant, and particularly as you start going through the developing world and start to see and understand the hundreds of millions of tons of urban landfill and municipal solid waste that is there and available to be repurposed, you start not only thinking about it from a renewable fuel question, but you also start thinking about from a public health perspective, because these areas are obviously degrading the local ecosystems, they're toxifying and rotting, they produce methane or nitrous oxide as well through their prevalence. And if that seeps into waterways or into the air, you also have the risk of pretty substantial social public health issues. So municipal solid waste is another really good example of one in which SAF can be a real underpinning and financially underwriting exercise of cleaning up your local environment. Taking a bit of a different term, we're now looking at crops, because this is quite a contentious issue, and very understandably, people are quite sensitive around growing crops for energy purposes. What is true is that we cannot be competing with food chains, right? We do not want to be discarding or cutting down further land which could have otherwise been repurposed for food production to grow energy crops. But what is true is that there are many areas and parts of the world where land is considered degraded or marginal and incapable or non-fertile enough to grow food. These are perfect areas in which regenerative agriculture options have been demonstrated as a proven avenue to producing feedstock for SAF, and whereby you look to find native solutions that might be drought resilient or climate resilient. And through their propagation and growth, not only do you have a feedstock, but they also represent an opportunity to re-optimize, re-fertilize, and regenerate on that land. A really strong opportunity for the farmers to get new revenue streams and ultimately have a long-term access to a new source of income. So we really like energy crops when they come on degraded or marginal land. A similar notion is cover crops. So essentially what you have during traditional harvest periods is something of a primary crop. That might be a food crop. In between that though, traditionally say over the autumn and winter period, you'll generally have the soil resting in its what's called a fallow period. In other words, kind of like sleeping overnight for us as humans, when you're recharging the batteries, getting ready for next year's crop and harvest. However, there are certain types of crops when grown over that fallow period that really benefit the soil and actually leverage and enhance the following year's potential of growing and yielding more amount of food crop. If you grow a non-food-based crop in this time, it is another perfect example of a scalable and ecologically impactful avenue toward aggregating and growing a feedstock. Finally, a new one is in recent light, is going to be leveraged through a different technology similar to hydrotreating, and that's the ability to take wet waste and sewage. Again, it's not exactly the prettiest topic, but it is no doubt low value to society, linked with a whole suite of different public socio-health risks, and it's going to be, by definition, very cost effective as a feedstock. So again, we're seeing so many different touch points in terms of the benefits of aggregating or growing these different sources that we can put into a circular economy in the form of a renewable fuel project. So overall, as a point to be really stressed, our feedstocks are going to be derived from low value byproducts, residues, wastes, or non-food crops. They are not going to be taken into food. This is something I can't stress enough, as we always see this complaint made in the public foray. If it is an energy crop, it's going to be purposefully grown and cultivated on areas of degraded or unutilized land, or coming from pre-existing industry activities, processes, and or cycles. So you're not going to be touching a new blade of grass. You will not find a SAF project that goes to a fertile area of land that could have been put towards other use and start clearing it for the sake of their own growth. That is not how the industry works. Rather, they're not meant to require additional resources, whereby if they're not repurposed, or if the energy crops on degraded land are not formed, all of the sort of implications look a little bit like this. So really, that's where I stress the point around SAF. It is very much a renewable fuel conversation, but it is equally a circular economy, social and nature impact play as well. So how that looks is really encapsulated in the type of things that we use to consider the sustainability credentials of our fuel. So the system that we have in place is run through a number of different bodies. The overarching body is the UN and ICAO, that's the International Civil Aviation Organization, and they've set up a program called CORSIA, or the Carbon Offsetting and Reduction Scheme for International Aviation. And that is basically a program for countries to demonstrate how within their jurisdiction, the emissions are being reduced from their aviation industry. And essentially they can choose to either utilize high integrity carbon offsets or sustainable aviation fuel. And to be accredited with those emission reductions, the SAFs have to be demonstrating how each of these different factors across carbon reduction, environment, as well as socioeconomic considerations are being taken care of. And there's a number of different independent bodies. To name a couple, you've got the Roundtable for Sustainable Biomaterials, or RSB, as well as another called ISCC, that are independently essentially auditing and verifying that these factors are being demonstrated across the full life cycle of sustainable aviation fuel. As a consequence, there is a robustness to the sustainability claims of SAF, and it is something that can also demonstrate and be a function of the just transition that's taking into consideration socioeconomic factors, not displacing work, but rather creating new revenue streams, deriving regional development, creating long-term climate resilient supply chains. Overall, the point to be made is the physical output of SAF is really only half the story. It is undoubtedly interesting for aviation because clearly for airlines, it is its #1 option to reducing its climate impact and carbon footprint. But when talking about it with the rest of the world, we can also see all of the different links that a SAF industry has to setting up sustainable supply chains, delivering land restoration, creating regional development, promoting biodiversity, and solving and helping promote better public health, and also, of course, delivering local energy security. So in all, hopefully I've now demonstrated some of the basics of SAF, the role of feedstocks, the different pathways that exist, and again, the criticality of this particular lever in the airline industry's net zero roadmap. Looking forward to taking your questions, and I believe the slides will be made available to you after the end of the show. Thanks very much.
Brilliant, thanks Dan. So we've already had a few questions coming in, so thank you to those people. We've got about 15 minutes for Dan to answer some questions. So yeah, any questions, drop them in the chat. I think a good one to start with, Scott's question. Given the limited supply of sustainable feedstocks today, what realistic pathways do you see for scaling availability fast enough to meet the UK's SAF targets by 2050? And who should lead that effort, government, industry, or feedstock producers?
Probably not going to be saying anything new here, but it's always going to be a combination approach. I think the point that I hope I demonstrated today is that we are not limited to any one pathway. So obviously from region to region, you're going to have different prevalent industries, different prevalent economic as well as environmental drivers and even challenges. And often they will inform the most relevant local feedstocks as well as the tied-in pathways. Now, just a comment about the UK, and it's the same for the EU as well. The policy in place at the moment really bans the utilization of crop-based feedstocks. It's a rather black and white policy. This potentially isn't the forum to discuss the validity or the logic behind that particular policy, but the point to be made there is what it really requires in the UK and the EU is the emphasis on waste-based feedstocks as well as the power to liquid options. So, for example, LanzaJet, my company, we're going to be producing a waste-based ethanol sustainable aviation fuel. So that's going to be taking a suite of local agricultural waste as well as woody biomass waste that I described earlier in the session, which is coming from local industries and farmers and growers in the region. So that's going to be a really important play. You've also got, for example, a company called Firefly, and they are taking the wet waste and sewage that exists, for example, in the United Kingdom and use their technology to develop a sustainable aviation fuel. There's a number of different companies that are going to be delivering power to liquids. So that's what I was referencing in terms of either the industrial off gases or the direct air captured carbon. So that's the gaseous feedstock route towards that. So as you can see, it's very much a basket of goods approach. It's not going to be any one particular pathway or feedstock, but it's always going to be informed around what are the local key industries and their sort of associated byproducts, waste and residues that aren't otherwise being repurposed.
Well, okay, lots of questions coming in. If we didn't have the constraint of trying to create a drop-in fuel, do you think we would find a more sustainable or more efficient fuel product? And I think that might feed into some of the other questions we've got coming up as well.
So really, it's a great question. So if I'm reading between the lines, it's sort of asking, is, for example, a liquid hydrogen or a hybrid electric sort of aircraft preferable? I mean, of course, we can always ask these ifs and buts. From my perspective, but before I go into the analysis there, each of these different technologies are going to play a really important role. I'm never one to subscribe to an either or, and which has already been demonstrated by my previous answer. But just to suggest, so already in general aviation, we're seeing the role of electric aircraft play there. They're clearly limited to their scope and size and payload, because as the range and the size of the aircraft increases, the size of the battery required to power that electric aircraft is going to increase. The weight is going to go up quite substantially, and clearly that's going to have capacity constraints on an aircraft. So there's sort of like a natural threshold there with electric. In terms of hydrogen, the other consideration beyond it being a drop-in fuel with existing sort of aircraft is just considering the implications from an infrastructure perspective. Really, when we talk about hydrogen as a fueling option, we've got to consider how long it's going to take to transform airports, the refueling infrastructure at site, as well as the availability of green hydrogen broadly, which is going to be applied in all different sorts of forms for not just aviation, but really all sorts of industries as part of their energy transition commitments. And so, as always, there's sort of opportunity costs and the best application of which levers being directed towards which sort of industry. So I think what I'm really trying to get at here is the propensity and the potential of these zero emission fuels are undoubtedly compelling, but the practicality and likelihood of implementing them in real time as an industry is still looking to grow, still looking to afford sort of people that sort of haven't flown on an aircraft before, which is probably about 80% of the world. There's growth aspirations and sustainability aspirations at the same time. And so whether that can be integrated at a global fleet level in real time, I'm just not so certain. That being said, domestic aircraft, short haul aircraft being replaced by hydrogen, I think is a very viable likelihood. Before 2050, we know about Zero Avia, We know also about Airbus's Zero-E program and their hydrogen propulsion aircraft. So I think this is definitely on the radar of the industry, and something that we hope to be seeing disrupt, I think, the global fleet by the end of 2050 at least. What I would say again about SAF is I'm really passionate about talking about the nature and ecological impact that good examples of SAF can have. So yes, it is a circular fuel in nature, and no, it is not a true zero fuel. But if it can financially underpin over, the 20-year shelf life of a biorefining asset, if it can financially underpin the aggregation of really harmful waste sources or the regeneration of long-standing degraded land, this is not only a carbon benefit, but it is a nature benefit that is invariably going to be quite resilient to climate change and the volatilities of different weather patterns. And so as a consequence, I sort of see the stacking effect across society, economics, and the environment and sustainability when it comes to the advanced biofuels and the power to liquids.
Cool. Yeah, I think the question was also asking about sort of fuel spec changes, and actually whether a small change in spec could, contribute to kind of a more efficient fuel, which I suppose feeds into challenges of, scaling up to 100% SAF. So what, sort of what would you say those challenges are, Dan?
Yeah, look, in terms of 100% SAF, it's clearly a big goal for the sector. At this point in time, it's right. There currently is a limitation to the amount of SAF that can be blended into an aircraft at this point in time, up to 50%. And that's because there's not the same prevalence of aromatics in SAF. And really what this is catering for are the previous generation aircraft. We've actually already had very successful trials of 100% SAF in 787s and some of the new engine aircraft technologies. And those have all been really successful and demonstrated the use case that 100% SAF is possible. However, I think off the top of my head, only maybe about 30% of the current fleet is operating globally with these new engine aircraft variations. So we still have a lot of previous generation aircraft flying around, and until we really see that global fleet renewed, really the implication, if you wanted to operate with 100% SAF, is you would have to split the fueling infrastructure at airports to just having a neat SAF pipeline and a Jet A1 pipeline, where some blending is taking place, no blending is taking place, or neat fuel, neat SAF is being delivered into wing, and that just requires all sorts of complex additions and infrastructure changes. Which, again, we know the airline industry. It's a resilient, long-standing industry, but it has its processes, and these kind of big changes don't happen overnight. So yeah, it's again, it's something we're on track with in terms of the new engine aircraft, but we need to really see the expediting of the global fleet renewal.
Yeah. So we've got a couple of questions on, I suppose, maybe future feedstocks. So I'll read them out. Maybe we can combine them.
Yep.
So have there been assessments on whether waste plastic could be a feasible feedstock? And we've also got a comment on, given UK water companies' poor performance with respect to sewage treatment, is there a viable new income stream for them in teaming with SAF producers? So I suppose the question is really on, what is the scope for future feedstocks? Now, we've discussed some of the ones that we've currently got in use now with valid conversion processes, but what's the scope for sort of using, this other waste material, perhaps?
Yeah, both really good questions. So when it comes to waste plastics, or really the industry refers to these, and it's always fun. It's a RFNBO, or renewable fuel of non-biological origin. The key being non-biological, so it's a fossil source. So a plastic is traditionally going to be originally made from a fossil source, and there is almost two schools of thought or philosophy, if you will. If the alternative is that plastic material ends up in landfill or being incinerated, this is clearly a negative for, everyone involved, the environment, ecology, and people. That being said, there is an emphasis on wanting to take low carbon feedstocks that are more biological in origin, because it's, considered to be not only better for the environment, but it means you're sort of not trying to extend the shelf life, for example, of plastic. And so there's really sort of fossil plastic, at least. So there's really sort of two philosophical sides to the story. Now, in the context of the United Kingdom, and another sort of similar debate around that, for example, is industrial off-gases. So you've got there a source that's non-biological in origin. It's a plant that will be running off fossil fuels, and it's producing emissions. Now, if they're not captured, they're going into the atmosphere, clearly. So the circular economy logic goes, well, let's take that before it goes into the atmosphere and convert that into a fuel. That being said, again, the counter argument goes, well, you don't want to prolong the shelf life of that fossil-based asset by valorizing its waste in the form of a fossil sort of off gas. And so you can sort of see both sides of the story, but in practice, there's going to be a sunset clause on the utilization of these renewable fuels of non-biological origin, and they're staggered between 2035 and 2041. So at least the industrial off gases, that's for sure. The use of plastics, I think there's an ongoing debate still happening. In my personal opinion, though, I think that this should be utilized as a feedstock. If the alternative is plastics are rotting in landfill or being incinerated, I think we're doing ourselves a disservice. It's a massively polluting waste stream, which I think we can be putting to better use. And again, it's better than utilizing the underground carbon stocks that fossil oil do. When it comes to the question around water, great point. I think this is one of the really interesting points around SAF production, is the byproducts that also come from a renewable fuels process, either at the end or during the process. So let me use LanzaJet ethanol to jet technology as an example. The first step in taking ethanol toward a renewable SAF is you have to dehydrate the ethanol into ethylene. That dehydration process creates water as a byproduct, right? And that water, with a basic cleanup, can be given back to farmers for irrigation purposes, or if you're to take it far enough, you could give it back as a clean drinking water. Similarly, with the wastewater and sewage perspective, absolutely. Essentially, what you're having with the wet waste and sewage is the splitting of the fat content and the water content. Once again, with the water content, if you treat it far enough, you give it back to the utilities and you can utilize it for irrigation or eventually drinking water. Now, again, there's always going to be a societal sort of public image type dynamic of how appealing that sounds for people, but undoubtedly this is something that represents an opportunity to really tailor to local economic, public health, and societal needs. So the public utilities, I think, are going to be very interested in the ability to get new sort of water sources. And very much from a biorefiner's perspective, these co-products represent a very interesting byproduct and revenue stream.
Okay. One on cost, I think. How does the cost of producing SAF compare against conventional fuel? Does it make economic sense overall?
It's a really good question. The thing about it is SAF is not one thing, as we've sort of seen in this session. So, whenever I get asked about what is the SAF price, it's unfortunately not as easy as just giving you a number, because it's always going to be dependent on what is the feedstock, what is the production method, which market are you selling into? To explain the logic a little bit, so let's go through the logic of, say, I'll give you two pathways that sort of are juxtaposed to one another. So in the case of heifer, you've basically had, in many respects, not a lot of greenfield projects. Not a lot of these facilities have needed to be built from scratch. They're rather retrofitted into a biorefinery from old existing fossil refineries that might have been decommissioned or taken as spare parts. The point to be made is, relatively speaking, from an expense standpoint or a capital expenditure standpoint, it's just a less sort of cost-intensive exercise. However, their feedstock, as we mentioned at the start today, is far more constrained. So in terms of used cooking oil, there are comparisons at the moment where used cooking oil actually sells for the same price as jet fuel does today. And that's not because used cooking oil is especially, attractive as a product, but it's just because there's a high demand for it. And so as a consequence, the operational expenditure linked with that particular pathway goes up. The reason why I'm sort of breaking this down is that the traditional approach to SAF pricing is sort of what we call a cost plus model. You're taking in all of your different types of costs, capital, operational, as well as then your production and process as distribution. It sort of layers up. And traditionally then on top, there'll be a little bit of a premium for the company to make a margin. Now, on the case of, say, an alcohol jet, such as ourselves, these are greenfield facilities. They need to be built from scratch. And so your CapEx is much, much higher. And that's really where the cost is going to be associated predominantly. Your feedstocks, though, given that they are far more abundant in nature, means that your operational costs come right down. So the idea is over time, your cost curve with these technologies leveraging waste will also come down, because you need, once you wash out the capital, your operational expense of waste-based feedstocks are really going to be quite low. The other point to be made, I think generally speaking, in terms of the way that SAF should be considered, is the product itself. Because I think there's sometimes a misconception that it is one thing and should be really compared like for like to Jet A1 fuel. The way I like to talk about it is SAF, you are selling decarbonisation as a service for the airline industry. So there is two products. There is the physical fuel, and then there is the decarbonisation component on top of it. Whereas Jet A1 is obviously just the former. It's just the physical fuel component. So the point to be made is that for those that are familiar with the way carbon accounting works, you've got scope 1 emissions, which are your direct emissions. So if you're an airline, that's your fuel combustion. Scope 2, we don't have to focus on quite as much. It's kind of like the power that goes into powering sort of the energy that you require. And then there's scope 3 is like your essentially the emissions associated from your customer base, essentially like the indirect emissions. So if you think of a corporate customer or any customer flying on an airline, in theory, if you're not demanding a seat on that plane, the business case for that plane taking off is reduced. And if, you know, demand from them really do come down, then that net flight might not fly at all. So the point to be made here, what we're also now seeing in terms of paying for this fuel, which I think traditionally at the moment, you're going to find is about 2 to 3 times more expensive than Jet A1. You're finding a scope 1, so the fuel component, your fuel component essentially being bought by the airline, and then a corporate customer partners with that airline and they pay the scope 3 component. It's a little bit of an oversimplification, but it is a very traditional route now. You'll find that corporate customers are partnering with the airlines and together they are sharing the cost basis.
Brill, I think we've got time for one more, and I want to try and leave it on a really positive note. So you might have to take your LanzaJet cap off here, Daniel, maybe. Looking ahead, what do you see as the most exciting breakthrough or opportunity for scaling SAF production?
Yep. No, I think the exciting part for me is that we've got so many different technological pathways compatible with all regions of the world. For me, it really lends itself to the discussion during the presentation, whereby not only do SAF industries have the propensity to deliver a renewable, viable avenue for airlines to reduce their carbon footprint, but we can create long-term, secure, sustainable supply chains really all around the world that are underpinned by byproducts, wastes, and harmful sources that are really serving no value to the local society. So we can create a SAF industry in India, in Brazil, in Australia, in Southeast Asia, wherever it might be, on the basis of what is most problematic for the local population, governments, and economy. We can turn things that are low in value into something that is really going to provide benefits, income, and a sustainable pathway for many, many different stakeholders. So that for me is always a source of inspiration and hope. It's not up to any one pathway, any one feedstock, but rather it's about catering to the local needs everywhere we go.
Brilliant. I think that's a really lovely place to finish. So thank you very much, Dan. Just got a few closing remarks. So to wrap up the Society's Sustainability Week, the Society is excited to launch an online quiz competition tomorrow, I believe, similar time of day, so over the lunch hour. Fun and engaging way to test your knowledge and showcase your understanding of sustainability in aerospace. And perhaps we've learned something today that might come in useful tomorrow. And I believe there's a free ticket to next year's sustainability conference on offer as well. So if you've got an hour to spare tomorrow, definitely go along. There's a QR code on the screen. I think there's also a link just gone into the chat, and of course all the details are on the website as well. We'd also like to request any feedback from today's session so that we can improve these, the society can improve these events in the future. Again, QR code on the screen, and I believe that will go into the chat as well. Thank you very much, Dan, for the presentation and for the Q&A as well. There's a lot of difficult questions there that I'd have struggled to answer that you answered really brilliantly. Apologies we didn't get through all of the questions in the chat, but hope that we sort of did it in an all-rounded way, that we touched on a few of the points you're all making. And then lastly, just like to thank all the delegates for coming. Thank you for engaging with the Q&A, and for yeah, that's about it. Obviously, stay in touch, and thanks once again.
Thanks, everyone.